Hello, geometry students. Welcome to our lesson of e-learning this week. We're going to be talking about three-dimensional figures today, and then we're going to follow that up with finding some surface area. All right, so when we talk about three-dimensional figures below, in previous lessons we discussed two-dimensional. So we discussed a circle, or we discussed a triangle, or we discussed a rectangle, or we discussed a square. All these have some type of base times height. There's only two dimensions. We're moving on to three-dimensional objects. So if I want to talk about a circle, or aka a ball that's three-dimensional, this is called a sphere. When you have an object where the base is a circle and it leads up to one point, this is called a cone. This would be considered a right cone because if you drop in altitude, it makes a right angle with the radius. This is technically called a prism. If you were told that the base was indeed a square, then we could say it's specifically a cube, but a cube is a type of prism. This is a pyramid, and the difference between a pyramid and a prism is in a prism, we'll discuss later, you've got two bases that are the same. In this case, you only have one base that comes up to a point, so this is a pyramid. And last but not least, if you think about most canned items, if you have, this is technically a prism, but instead of having a base that is a polygon, it's a circle, and therefore we categorize this as a cylinder. All right, so just a couple of notes to kind of go through. A three-dimensional figure or a solid is bounded by a flat or curved surfaces that encloses a single region of space. In general, a three-dimensional figure, it has to have a length, a width, and a height, or a length, a width, and a depth. All right, so now we're going to talk about the vocabulary word polyhedra. A polyhedra is a solid that is bound by polygons only. So if we look at the difference between what is a polyhedra and what is not a polyhedra, basically in this case, you have some type of circle that is involved with your shape. And if there's a circle involved with your shape, it is not a polyhedra. If you look at the ones that are, all of the sides, if you look at all of the sides of the shape, it is some type of polygon. So a polyhedra is a side that is bounded by polygons, and to name it, you use the shape of the base, and this is huge. Prisms have bases that are parallel, congruent polygons. You have two. And if you look at the sides are rectangles. A pyramid has just one base that is a polygon, and then it comes up to a point, and you will notice that those sides are triangles. So you're asked to tell which solid is a polyhedron, and if not, name it. We can immediately X out 3 and 5. 3 and 5 are not polyhedra because there is some circular element to that. Now, number 3 is specifically a cone. That's just for your information. Number 5 really isn't anything. It's, I guess, half a cylinder. On number 1, though, number 1 is a polyhedra. And when you look at the base is a rectangle. Because this has two rectangular bases, this is a rectangular prism, not a rectangular pyramid. If we look at 2 is a pyramid because it only has one base. That base has 6 sides, so this is considered a hexagonal pyramid. Notice how each of the other sides are triangular, they're not rectangular. And number 4, this is another example of a pyramid. The big idea is there's only one base. Please note that because all 4 sides are congruent and you're marked, this is a 90-degree angle, the base is a square, so this is a square pyramid. And last but not least, number 6 is often made a mistake. People think that, oh my gosh, I see the triangle, so it's got to be a pyramid. Please be careful. In this case, you have a triangle and a triangle. Those are two bases. And then if you look at the sides are rectangular. So this is a triangular prism. All right, so let's move on and talk about the parts of a polyhedra. In a polyhedra, it is a solid that is bounded by polygons. So your faces are the polygons that form the polyhedra. So if you think of a box, each of the sides of the box is a face. The edge is where two of those sides come together. And the vertex are the points that each of them make when they join up with another side of your solid. So if you think about this chart, if we have a solid, in this case, this first solid is a rectangular prism. If you want to count the vertices, I have 1, 2, 3, 4, 5, 6, 7. I have 8 vertices in that rectangular prism. Now, if we want to count edges, all right, so let's erase those. If I want to count edges, the edges, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that make up that rectangular prism. And if we want to talk about faces, those are the sides of the box. So you have the front and the back, top, the bottom, and then the two sides, which gives me a total of 6 faces. Now let's look at the next problem. The next problem is an hexagonal pyramid. So when they want me to talk vertices, I have 1, 2, 3, 4, 5, 6, 7 vertices. When they want me to talk about edges, I have 1, 2, 3, 4, 5, 6, and then you have everything in the base. 1, 2, 3, 4, 5, another 6. So that gives me a total of 12 edges. And now when we want to look at the triangular pyramid, it's a triangular prism. All right, when we want to count vertices, I have 1, 2, 3, 4, 5, 6 vertices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges. And last but not least, you have the front and the back, which are your bases. And then you have the other 3 sides, so you have a total of 5 faces. Now, what I just did was the long way. I physically counted each of those. But we do have Euler's formula, which tells us that we have this relationship that this equation works all the time. The faces plus the vertices minus the edges are always 2. Let's verify. All right. So Euler's formula tells us if we take the faces plus the vertices minus the edges, it equals 2. Let's see if that holds true. If I have 6 faces plus 8 vertices, that's 14, minus 12 edges, I get 2. Let's look at it for the hexagonal pyramid. I have, I think I forgot to write that in there. I think we forgot to do faces. We have 1, 2, 3, 4, 5, 6. We have 7 faces. All right, so if I have 7 faces plus 7 vertices, that's 14, minus 12, it does equal 2. And in the triangular prism, if I have 5 faces plus 6 vertices, that's 11, minus 9, that equals 2. So they do satisfy Euler's formula. So what could some of your homework problems look like? Well, if you know that you have 5 faces, 5 vertices, you're welcome to do this mentally. But I have an equation of faces plus vertices minus edges equals 2. This problem tells me I have 5 faces plus 5 vertices, and they want to know the edges. So 10 minus the edges is equal to 2. So negative edges is equal to negative 8. So I would have 8 edges on this problem. And on problem 10, faces plus vertices minus edges equals 2. I don't know the faces. I have 8 vertices with 12 edges. So faces minus 4 equals 2. So this object has 6 faces. If you would like, you can feel free to pause this video and you can address the first page of your homework, which is Unit 11, Lesson 3 practice. All right, this is the second half of today's lesson where we're going to talk about the surface area of prisms, cylinders, and this is where, for the sake of e-learning and just trying to make sure that you get some basics, we are not going to discuss pyramids and cones. All right, so again, we are only going to talk about the surface area, meaning how much wrapping paper would it take to cover exactly a solid, but we're only going to discuss prisms and cylinders due to e-learning. If we had a regular learning environment, we would. Okay, so the first thing you need to be clear about are the following: what a base is and what we call a lateral surface. A lateral surface are the surfaces of the solid that are not the base. So if we look at this cone, this is the base. That means, actually, let me color code this correctly. Hold on. Let's make the base green. All right, so this is your base. In your prism, these are your bases. In this pyramid, there's your base. And in a cylinder, your top and the bottom are the base. I get it that we're only going to be doing surface areas of those today. But I still think it's important that you understand that when we discuss lateral area, all right, the lateral surface is everything but the base. It's the sides, so the front, back, and side of that prism. It would be all of those triangular sides that meet. And in a cylinder, it would be the label that would be on a soup can. The surface area is the sum of all the areas of all of the surfaces. So one way that you can go about these problems is to figure out the area of each face and add them up. That absolutely works. But we are going to talk about some formulas that might be helpful that make it more efficient. All right? So we're going to talk about our problems in terms of the base area, and we're going to add to it the lateral area. So when we talk about the surface area of a prism, it is the base area plus the lateral surface area. My base is length times width. And then if you think about the lateral area, you are welcome to find the area of each and add them together. Or what you can do is take the perimeter of your base and multiply it by the height, and that's just a little bit more efficient way to find the area of a prism. So let's do our first example. In this prism, I am going to refer to this part as the base. So I know I have to find the base. When I use the capital B, this means the area of the base. All right, and the area of the base, if this is 15 and this is 15, it's a square. My area is 15 times 15, which gives me 225. The perimeter means the perimeter of the base. And since the perimeter is 15 plus 15 plus 15 plus 15, I can take 15 times 4, and that gives me 60. If I am using this as my basis of the prism, that means my 32 is the height. So then, now that I have all of this, I can plug it into my formula. I know that the surface area is 2 bases, and then my lateral area is perimeter times height. So that means I have 2 times 225 plus 60 times 32. I will let you do that in your calculator for the sake of time on the video, and you end up with 2,370 centimeters. And remember, we measure this in square units. Okay, on this problem you'll see is a little bit more complicated because getting the perimeter will be hard. Again, the first thing you have to determine is that this is a prism. It's a prism because I have 2 bases that are triangular. You need 3 measurements in order to find the surface area. You need the area of the base, you need the perimeter, and the height. So the area of the base is 1/2 base times height because it's a triangle. So that means it's 1/2 times 8 times 5, and that gives me 20 units. If these are my bases, then that means my height has to be 10. What is difficult is the perimeter. The perimeter, we know that this is 5 and this is 8, but I need the hypotenuse in order to figure out the perimeter. Well, in order to do that, I have to do Pythagorean theorem. So I have to take 5 squared plus 8 squared equals c squared. That's 25 plus 64. And I'm letting you know, again, I'm going to let you do the calculator work on your own, but this is approximately 9.4. So in order to get my perimeter, I have to take 9.4 plus 5 plus 8, which gives me 22.4. So now I can find my surface area of the object. And the surface area for a prism is equal to 2 times the base plus the perimeter times the height. My base is 20. I substitute in 22.4 for the perimeter, and the height is 10. I'm going to shove that into a calculator, and I get 264 square feet. All right, the next two, the surface area of a prism, these are more complicated because your bases are not nice, neat rectangles. In this case, we have a hexagon. So, again, this is a hexagonal prism because I have a hexagon base and there are 2 of them. So in order to use my surface area formula, I have to know the area of the base. I need to know the perimeter of the base and the height of the object. The base is the one that's going to be a pain in the butt to find. The perimeter is actually not too bad. Each side is 4. So I have 6 sides, so I know that the perimeter is 24. Your height is the distance between each of the bases, so that's 8. In order to find the area of a polygon is 1/2 apothem times the number of sides times the length of the side. So when I use 1/2 apothem times the number of sides times the side length, I don't know the apothem. I know that I've got 6 sides and I know that each side is 4, so I have to find the apothem. All right, so we have to use what we did in the previous lesson. I know that I can find this angle by taking 360 divided by 6. So that means that angle is 60 degrees. But then I have to cut that in half because that's my apothem. That means this is 30, and this would be 2 because the whole side is 4. Now, in order to find the apothem, you are welcome to use special right triangles. If you want to use 30, 60, 90 triangles, then I would double the 2. This would be 4, and this would be 2 root 3. Or you can use SOHCAHTOA. 2 is opposite. A is adjacent, so that's tangent. So the tangent of 30 is equal to 2 over A. That means A is equal to 2 over the tangent of 30. And if I take 2 over the tangent of 30, I get 3.4. Actually 3.5 when we round. Please note that 2 radical 3, if you did it by 30, 60, 90 triangles, is also 3.5. All right, so regardless of how you do it, A is approximately 3.5, so that's going to go in for my apothem. And when you take 1/2 times 3.5 times 6 times 4 in a calculator, that is going to give you a total of 42. So now I can go to my main surface area formula. Surface area is 2 times the base plus perimeter times height. So that is going to be 2 times 42 plus 24 times 8. And again, please, you can verify on a calculator. You get 276 square feet. Last but not least, in this problem, we have a triangular prism. And what you need to notice on this problem that it might not be clear is that this is an isosceles triangle. So your base is isosceles. This is 6, and that's 2. So again, since this is a prism, why do I know it's a prism? Again, it's not a right triangle, guys. It's just an isosceles. But I have two sides, isosceles triangles, that are the bases, and the rest of the faces are rectangular. So I need to know the area of the base, I need to know the perimeter, and I need to know the height. And this is a problem, again, where the base is going to be kind of a pain in the butt to figure out. Your perimeter is not bad. It's 6 plus 6 plus 2, and that gives me 14. The height between your bases is 3, but we just have to figure out the base. So instead of looking at the triangle this way, I think it's easier to look at the triangle this way. This is the height we don't know. So I can, if this is 2, that means this is 1, and I can do Pythagorean theorem in order to find the height. 1 squared plus height squared equals 6 squared. 1 plus h squared equals 36. H squared is equal to 35, and the square root of 35 is approximately 5.9. So to find the area is 1/2, the base is 2, the height is 5.9, and 1/2 of 2 is 1, so the area is also 5.9. So now I can use my main surface area formula. My surface area is equal to 2 bases plus the perimeter times the height. So that's 2 times 5.9 plus the perimeter of 14 times 3. And when you put that in your calculator, you get 53.8 square feet. That concludes finding the surface area of prisms. We are now going to talk about cylinders, and they're actually easier, and I only have 2 more examples. So I want to let you know that all prisms basically have the same idea of 2b plus perimeter times height, except in a cylinder, your base is a circle. So that's why we have 2 pi r squared, because the area of a base is a circle, and the area of a circle is pi r squared. Furthermore, when you talk about perimeter times height, if you're wondering, well, Nap, why do we have 2 pi rh? That's because the perimeter of a circle is actually circumference, and that's 2 pi r times the height. So that's where that formula comes from. So when you do the surface area of a cylinder, you basically need the radius and the height. So in problem 5, it was pretty much spelled out for you. The radius is 3, the height between the circles is 2, and then I just plug it into my formula. The surface area of a cylinder, and this is a cylinder because your bases are circular, is 2 pi r squared plus 2 pi rh. So I take 2 pi times 3 squared plus 2 pi times 3 times 2. And here's what I want to talk about. 2 possible ways that you can give your final answer. One way, and sometimes you'll see this on an ACT, this is why I'm going over it, is they might ask you to find the answer in terms, let me rewrite that a little bit better, in terms of pi. Okay, what that means is that you actually don't type pi in your calculator. The first term is 3 squared, which is 9, 9 times 2, which is 18 pi. The second term is 2 times 3, which is 6, times 2, which is 12. In other words, I'm just doing the number piece. I'm treating it like a variable. So 18 pi plus 12 pi gives me a total of 30 pi yards squared. Another way that you can do this is just by plugging this in your calculator. And if you plug in your calculator, you will get a decimal approximation. And when you type it in your calculator, you should get 94.2 square yards. So friends, those are equivalent. You just need to look at the directions if they want it in terms of pi, or if you were on an ACT and all of the choices were in terms of pi, it's less work than plugging it in your calculator to get that decimal approximation. And let's do one more, and we will call it a lesson. Again, when you're finding the surface area of a cylinder, all you need is a radius and a height, which they gave you. And then we're going to plug it into my formula. So your surface area is equal to 2 pi r squared plus 2 pi rh. I plug in my values for r and h. Again, if the question wants your answer in terms of pi, all right, 8 squared is 64. 64 times 2 is 128 pi. 2 times 8 is 16. 16 times 12 is 192. So in terms of pi, you would have 320 pi square inches. And if they wanted a decimal approximation, then when you plug that in, you should get 1005.3 square inches. So now you're ready to do page 2 of your learning opportunity. Remember that if you have any questions, you can contact me via Zoom at 11 a.m. on Tuesdays and Thursdays. Enjoy!